The water cycle, the foundation of rainfall. Rainfall is a critical component of the Earth's water cycle, a continuous process that moves water between the atmosphere, land, and oceans. The water cycle begins with the evaporation of water from bodies of water like oceans, lakes, and rivers, where it transforms into water vapor and rises into the atmosphere. This cycle is fundamental to understanding why rain falls from the sky. Evaporation and water vapor formation. The first step in rain formation is evaporation. When the sun heats water on the Earth's surface, it turns into water vapor, a gaseous form of water, and rises into the atmosphere. Plants also contribute to this process through transpiration, where water evaporates from their leaves. The accumulation of water vapor in the atmosphere is crucial for the next stage of rain formation. Condensation, turning vapor into clouds. As water vapor rises, it encounters cooler temperatures at higher altitudes. This cooling causes the water vapor to condense into tiny droplets of liquid water, forming clouds. These droplets are incredibly small and light, allowing them to stay suspended in the air. Clouds are essentially collections of these condensed water droplets, and their formation marks the beginning of the process that leads to rainfall. Cloud formation and saturation. As more water vapor condenses, the cloud grows and becomes denser. Eventually, the cloud reaches a point of saturation, meaning it holds as much water as possible. At this stage, the cloud is heavy with moisture, and the tiny water droplets begin to collide and combine into larger droplets. The cloud's capacity to hold water diminishes, setting the stage for precipitation. Precipitation. The droplets fall. When the water droplets within a cloud become too large and heavy to remain suspended, they begin to fall to the earth as precipitation. This precipitation can take various forms, including rain, snow, sleet, or hail, depending on the temperature and atmospheric conditions. Rain, specifically, occurs when the droplets remain in liquid form as they descend through the atmosphere. The role of temperature. Temperature plays a critical role in determining whether precipitation falls as rain or another form. In warmer conditions, the water droplets stay liquid and fall as rain. In colder conditions, the droplets may freeze into snow or ice before reaching the ground. This variation in temperature is why rain is more common in warmer climates, while snow is prevalent in colder regions. Atmospheric pressure and rainfall. Atmospheric pressure also influences rainfall. Low-pressure systems are associated with rising air, which cools and condenses, leading to cloud formation and potentially rain. High-pressure systems, on the other hand, are typically associated with descending air that discourages cloud formation, resulting in clearer skies and less likelihood of rain. The impact of geography. Geography affects where and how often rain falls. For example, areas near large bodies of water or those at higher altitudes tend to experience more rainfall due to the increased availability of moisture and the cooling effect of elevation. Conversely, deserts and areas far from water sources receive less rain, as there is less moisture available for evaporation and cloud formation. Human influence on rainfall. Human activities, such as urbanization and deforestation, can also influence rainfall patterns. Urban areas often experience more rain due to the urban heat island effect, where cities generate heat that increases local evaporation rates. Deforestation, on the other hand, can reduce rainfall by decreasing the amount of water vapor released into the atmosphere through transpiration. Conclusion. Rain falls from the sky as part of a complex interplay of processes within the Earth's water cycle. From the evaporation of water to the formation of clouds and the eventual precipitation, each step is influenced by temperature, atmospheric pressure, and geography. Understanding these factors helps us appreciate the essential role that rain plays in sustaining life on Earth, replenishing water supplies, and maintaining ecosystems.